It turns out that this left string, the stuff to the left of the vertical bar, can be implemented by a stack. And that's because we only do reduce operations immediately to the left of the vertical bar. So it's always some suffix of the string to the left of the vertical bar where the reduction is happening. So what a shift move then does is to push a terminal onto the stack. It reads one token of input and pushes it on the stack. And then a reduce pops some number of symbols off of the stack. That's the production right-hand side. And then it pushes one non-terminal onto the stack. That's the production left-hand side. Now it can happen that in a given state that more than one action, shift or reduce, may lead to a valid parse. So in particular, if it's legal to shift or reduce, if you could do either one of those things, then we say there is a shift-reduce conflict. The parser could either read one token of input and push it on the stack, or it could perform a reduction. If it's legal to reduce by two different productions, then there is what is called a reduce-reduce conflict. Okay, so reduce-reduce conflicts are always bad, or almost always bad. They indicate usually some kind of serious problem with the grammar. Shift-reduce conflicts are not good, but they're often easier to remove. So if you have reduce-reduce conflicts, particularly when you're building your grammar for cool, then you're doing something seriously wrong. If you have shift-reduce conflicts, then that's almost to be expected because you're probably going to need to use precedence declarations to remove them, and we'll talk about that some more in another video. But in general, if you have either one of these conflicts, it means that there's some state in which the parser doesn't know what to do, and you either need to rewrite the grammar or give it a hint as to what it should do in order to successfully parse your language.